So a set is a unordered unordered collection of distinct elements. Unordered collection of distinct elements. Distinct elements. When I was working in an office, I used to work on Java, and there was a interface or parent class called as collection. There's something to do with sets. So even if you give the repeated values, when you call that class, which is basically a set, it will return the elements with unique values. Means even if you give the set values to be 1, 2, 3, 3, if you give, let's say, a is equal to 1, 2, 3, 3, 4, right? So even then, when you it will return a to b, it will always return a to b 1, 2, and 3, 1, 2, 3, and 4. So even if any element is coming more than once in set, we are only dealing with distinct elements. So duplicates are not allowed. Duplicates are just ignored. Okay. So cardinality of A. What is cardinality of a set? Cardinality of the set is number of elements in the set. So cardinality of A is cardinality is represented like this. So this means cardinality of the set, which is equal to number of elements in the set. So cardinality of A is 4. Okay, cardinality of A is 4. And what are the elements of A? 1 is an element, 1 belongs to A, 2 belongs to A, 3 belongs to A, and 4 belongs to A. So because these are 4 elements, so cardinality is 4. Okay. So let's take only 1, 2, 3, 4. Let's take 1, 2, 3. Set is an unordered collection. Unordered collection. So we are just concerned with this distinct elements. So any other set, let's say if I take another set, any set with the same elements, 1, 2, 3 only, B is 3, 2, 1, and any other set C is uh, 2, 1, and 3. Then all of these are equal sets mutually. A is equal to B, A is equal to C, B is equal to C, B is equal to A. So I was talking about that class in Java, which is a set. So what happens is every time that you call a set, it will return the elements, same elements, but their order may not be same. Every time the set is called, then what it returns is a set with same elements, but the order can be changed because order is irrelevant. We are not concerned with the order in which we are collecting the elements, like what element is to be collected first, or what is second element, what is third element. So instead, we don't talk like that. That what is the first element of a set, what is the second element of a set. It's just what are the elements of set. This is not an array. Array is an ordered collection of okay, later on. But array is an ordered collection of similar data types. Leave it. So all of these elements are same. A is equal to B. This is about the equality of two sets. Two sets are equal if their elements are same. If they have same elements, then both sets are equal. What is a subset of a set? What is a subset? So we are concerned with set A right now. So what is a subset of set A? If there is any other set whose elements are from set A, what does it mean? It means that a set B is said to be a subset of, a subset of set A. A set B is said to be a subset of set A if all the elements of B, all the elements of B is also an element of A. Is also an element of A. So take two sets. B is equal to 2, 3, and C is equal to 3, 5. Now, out of these two sets, B is the subset of A, but C is not a subset of A. B is a subset of A, and C is not a subset. C is not a subset of A. Why? Because all the elements of B, which is 2 and 3, all of the elements of B is also in A, or the elements of B are from set A only. But elements of C are not from set A alone, because C contains 5, which is not which is not an element of A. So 5 belongs to C. This is the symbol to represent. So on this side, this is the element, okay, and this is your set. So belong symbol means that this element belongs to this set, or this is the element of this set. So 5 belongs to C, okay. But 5 does not belongs to A. So there is at least one element in C that is not from A. So C is not a subset of A. Okay. If a set is given to you and you are asked to form a subset from this set, so you know that the elements for a subset has to come from A only. Has to come from A only. And from the definition of a subset, the set A is a subset of itself. From the definition of subset, if all the elements of B, if all the elements of B is also an element of A, so definitely all the elements of A is an element of A. So every set is a subset of itself. Every set is a subset of itself. So every set is a subset of itself. Now, how do you form a subset? If a set is given to you, like A is given to me, and if I have to form a subset of A, how can I do that? So it is clear that the elements of that subset is going to come from A only. Is going to come from A only. So how can we form a subset? Uh, for every element, I have two choices. That in my subset, whether I will include this element or not. I may in my subset, I may include one or I may not include one. Okay, let's say I don't include one, but I include 2 and 3. Then this is what that subset is. So you can say that B is formed. How B is formed? Because I had two choices for every element. If I choose all of the element, then I get the set itself. And that is what it is. Every set is a subset of itself. I don't choose one. Every element has two choices. So for one, I am not choosing it to be a part of my subset. But other elements, 2 and 3, is a part of my subset. So B is a set which happens to be a subset of A. So let me write all possible subsets of A. So elements of A is 1, 2, 3. Okay. Now I know one of the subset is the set itself, and that is when we choose all of the element to be a part of, to be an element in my subset. If I choose every element of A to be an element of my subset, then what we get is this set 1, 2, and 3, and this is nothing but the set itself. So this is one of the subset. This is trivial subset. One of the trivial subset of a set is the set itself. That is when we choose every element to be in my subset, to be an element in my subset. Now let me choose the elements. Let me choose the subsets of cardinality 2. So the cardinality of the subset is going to be from 0 to 3. The length, the cardinality of A is 3, and my subset, the elements of my subset can be from set A only. So the maximum length of my subset will be 3. That is when the subset is the set itself. And for any other subset, what I'm going to do, either I'm going to pick 2 elements and not pick 1 element, or I'm going to pick 1 element or not pick 2 elements, or I'm going to not pick any of the element, because for every element I have 2 choices. So let me write possible subsets of cardinality 2. So for cardinality 2, for every combination, so if for every combination I am getting one subset. So let's say for cardinality 2, I have to select 2 elements in my set. I have to select 2 elements in my set, right? Let's say I don't select 1. If I don't select 1, and then I will select 2 and 3, and this set is 2, 3. Similarly, one another possibility is that I don't select 2. If I don't select 2, then my set, I get another subset which is 1 and 3. So as you can see, to form a subset, for every element of A, you have 2 choices. Either this element is in your subset, or this element is not in your subset. And because of this, you are getting different combination. In this combination, all 1, 2, 3 is in your subset. In this combination, 1 is not in your subset, 2 and 3 is in your subset. So in this way, how many combinations you will get? This is very much like 1, 2, 3 is very much like Boolean table with 3 Boolean variables, and every variable can take value 0 or 1. So number of combinations possible is going to be 2 power 3. So here it is number of subsets possible for this set A is going to be 2 to the power 3. This time I will choose 1 and 2, and I will not choose 3. So my subset is 1 and 2. So these are all the subsets of cardinality 2. Now I will choose all possible subsets of cardinality 1. How can we do that? So for 2 elements, I'm not going to make it a part of my subset, and for 1 element, I'm going to put it in my subset. So in how many ways can you make the cardinality 1? So every time I'm just going to select 1. So let me select 1, then 2 and 3 I'm not selecting. I'm not selecting it to be my to be an element in my subset. So this is my subset. Then I'm selecting 2. Then I'm selecting 3. Now there is one more type of set. Okay, I've not discussed the types of sets, but there's one type of set which is called as empty set. Empty set is, okay, how a set is represented. A set is represented by curly braces with elements, with all the elements separated by commas. So the elements of A is 1, 2, and 3. So it is enclosed between the elements of the set is enclosed between 2 curly braces, and they are separated by commas. So if a set does not have any element, then you write it like this. What does it mean? That this is a set. No doubt this is a set, but it has no element. Okay, that's what a empty set is. A set, it is a set, but no element. And it is also can be it is also represented as phi. So what phi is? Phi is equal to empty set. So one of the possible combination is that you don't select any of the element to be in your subset. So and that is your phi or this. So total number of subsets of set A is 8. There are 8 total subsets. These two, this and this, they are called trivial subsets. For every set, the set itself and the empty set, they are the trivial subsets of a set. Empty set is a subset of any set. Okay. For any given set, the set and the empty set, these two are trivial subsets of a set. Trivial subset. And remaining, so these two are trivial and remaining are subsets. One more thing, there is something called as proper subset. So what is a proper subset? Proper subset is a subset of set that is not the set itself. Or in a proper subset, you have the cardinality of proper subset has to be less than the cardinality of the set, or there is at least one element, and this is the real definition. A proper set subset of a set is when there is at least one element in the set which is not there in subset. So apart from this, for every other subset, there you can find at least one element which is in A but not in the subset. Like for this example, one is not a part of this subset, or one is two is not for this subset, three is not in this subset, two and three is not present in this subset, one and three is not present in this subset, one and two is not present in this subset. None of the element is present in this subset. So all of these subsets are proper subset. And for proper subset, how do we represent proper subset? Uh, for example, let's say this is my set B. B is equal to 2 and 3. Then uh, how do I represent that this is a proper subset? The symbol for proper subset is this. So that B is a proper subset of A. Okay. So it is also a subset. So you can write, let's say if this is C, then you can write C is a subset of A. But C is also a subset of A. This is true also, and this is true also. Okay. But in this case, this is only a subset of A. This is only a subset of A. This 1, 2, 3, this is not a proper subset. This is not a proper subset, but this is a subset. Okay. So as you can see that for a given set of length 3, the total number of subsets possible is 8. If the size of the set is n, if the cardinality of the set is n, then what is the total number of subsets possible? It is going to be 2 to the power n, because then how many combinations are possible? 2 to the power n. Okay. So if the cardinality of A is n, the number of possible subsets of A, number of possible subsets of A is equal to 2 to the power n. What is powered set of A? What is a powered set of A? Power set is a set of all the subsets of A. All the subsets of A. So what is the power set of A? Power set of A is going to be equal to all of this. Means power set of A, in the power set, each element is a set. So set can have a set as an element. So it is possible. It means, of course, just it has to be distinct element. Set can have anything in as its element, anything. So not numbers. Like in the introductory video, student one is a set. Is can be one element. Student two can be another element in a set of students. What is the power set of A? Power set of A is 1, 2, 3, 2, 3, 1, 3, 1, 2, 1, 2, 3, and 5. So this set is a power set of A. So if the cardinality of A is n, then what is the cardinality of power set of A? If cardinality of A is n, then what is the cardinality of the power set of A? This is equal to 2 to the power n, because there are 2 to the power n elements. There are 2 to the power n subsets of a set. So each subset is an element of power set. So the cardinality of power set is 2 to the power n. This this is trivial subset. This is trivial subset. Now you can say that this is one of the representation of set. This is how one of the way to represent a set is, you have a curly braces and that encompasses all the elements which are separated by commas. There's another representation of set. You can represent set using a statement of English language that is called set builder notation. So that statement itself encompasses all the elements, all the possible elements. How? For example, in this case, A is equal to 1, 2, 3. I can write in English statement something like A is equal to X, such that X belongs to natural number and X is less than 4. Then this is nothing but this. This n is also a set of natural numbers. N is set of natural numbers. So this is the example where number of elements is 3. But there are the sets can be finite set or it can be an infinite set. Some of the very popular infinite set, one of them is natural number, set of natural number. So which is n is set of natural numbers. Similarly, z set of all integers, q set of all rational numbers, r set of all real numbers. These are some of the popular infinite sets. Okay, what is the significance of set and subset? What is the significance of it? All of the subsets of this set A are nothing but set in themselves. They are the elements has to be decided from A. So it's like the world of A. So it is, in other way, you can understand this as that in the world of A, these are all possible sets that can be. In the world of A, this is the all possible sets that can be. For example, take the case of university. In university, you can have one set of students. Some students may be learning physics. Some students may have opt to learn chemistry. Some may have opt to learn mathematics. Some may have opt to learn about politics. Okay, so every set, so all the other sets means a student who learn physics, they are going to be the elements of these sets are going to be from the elements of set of students only. So set of students is like a universal set, and every other set in the context of university is a subset to this universal set. So likewise, in this case, A is a universal set. So universal set, A is a universal set, and every other set in the world of A, every other set is a subset to this A, because every other set, the elements will come from A only. Similarly, in case of university, for every other set, like physics students, set of chemistry students, set of politics students, set of English students, their elements are going to come from set of students only. Now, it might happen that let's say there is one subject where every student is learning that subject. For example, English literature. Everyone is learning that English language. Then, in this case, this subset is the set itself. Like this is the scenario of this, that that every set is a subset of itself. Similarly, there must be some subject where teachers just come to the classroom, but there is no one because nobody has opted to study that subject. Teachers just getting the salary, and the classroom is vacant. What can that subject be? What can that subject be? Let's say history. Let's say it's a college. College name is University of Science, but there is a history subject also, and there's also a history teacher in it. But nobody is interested in studying history. So in the set, so there is a set, that set of history students or students of history. So there is a set, but there is no element in it. That is what is empty set is. Okay. So this is the significance of about set and subset. So what is a universal set? A universal set is a set that is a superset to every other set. So for a given context, there is one universal set. Context of city population, what is the universal set? It's the set of all people in the city, and set of men, set of women. These are the subsets. So men or women, in these subsets, the element has to come from this universal set, which is the set of all people. So this is what it is. There's another representation of set. Right? I talked about this is one representation, curly braces, and inside of the curly braces you write every other element with a means separated by commas. The other notation is set builder notation, and there's another pictorial representation which is called as Venn diagram. In the next video, we will learn about set operations. So most of the set operations or the next video maybe will be properties of sets. All of them are very self-intuitive. Self-intuitive means you look at the property and you are like, obviously it has to be like that. And even for some properties where you don't get that obvious feeling, those properties can easily be visualized using Venn diagram. So maybe not in this video. In the next video, I will first start with Venn diagram, and then I will also cover set operations. Thank you very much.